Good day, everyone. We are Group 4, and we will be presenting Problem 6.16 for our group assignment number 2. Our members consist of Victoria Casanova, me, Kalkin Jorge, Bryan Paraiso, Amerina Peñaflor, and Jaime Sia. Our presentation outline consists of first, our topic explanation, second, our problem overview, and lastly, our presentation of our answers. Now, I will be explaining our topic presentation, which will consist of the background, the suggested model, and the pros and cons of the suggested model. Just to give a brief overview of the problem, basically the problem suggests is that a local airline company plans to purchase a tractor for its luggage purposes. However, a mechanized system will be put in place in 3 years, in which the tractor will not be needed necessarily anymore, although for economical purposes, the company still wants to keep it. And the main goal is determining when a new tractor should be bought with the least resource allocated as possible. Now, this is where the group suggested model comes in. The group suggested that a cost minimization model will greatly benefit the scenario, since its main rule is to seek and calculate the right balance between two inputs or factors, which is currently present in the problem. This model also often leads and determines the most efficient way of production in a company. And of course, in every model, there are pros and cons. First off, we would like to discuss the pros. So what are the pros? First, it achieves the most cost-effective production. Second, it simplifies processes and procedures. And lastly, it usually results in higher profit and better cash flow. And moving on to our cons. First, it usually lacks to handle unexpected or short-term increases in demand. And of course, it may surprise and or annoy other functions of the company. Thank you.
Now we're going to be having an overview of the problem and see what management is trying to achieve through this model. This is what the problem states. At a small but growing airport, the local airline company is purchasing a new tractor for a tractor-trailer train to bring luggage to and from the airplanes. A new and mechanized luggage system will be installed in 3 years, so the tractor will not be needed after that. However, because it will receive heavy use, there's going to be running and maintenance costs, which will increase rapidly as it ages. It may still be more economical to replace the tractor after 1 or 2 years. The next table gives the total net discounted cost associated with purchasing a tractor. Purchase price minus trade-in allowance plus running and maintenance costs. At the end of year I and trading it in at the end of year J, where year 0 is now. So what is management trying to achieve? So it is stated here that management wishes to determine at what times, if there's any, the tractor should be replaced to minimize the total cost for the tractors over 3 years. So we should formulate a network model for this problem as a shortest path problem, and also formulate and solve a spreadsheet model for this problem. The objective of the model is to minimize the total net cost of the purchases of tractors over the next 3 years, or tractor over the next 3 years, with the consideration of increasing running and maintenance costs. So we could see in each year, it's a different cost because of running and maintenance costs. And we would also have to take in consideration that there would be a new mechanized luggage system after 3 years. It was noted that the tractor would not be used after acquiring the new mechanized luggage system, but it is still explained how the tractors are still going to be used heavily during the 3-year period. It is now the problem of management to see when the company must buy a new tractor given the running and maintenance costs per year. So the model to solve this minimization problem will be revolving around the concept of minimum cost flow. And it is the goal of management to know when the tractor should be replaced to minimize the total cost. The problem presented falls under network optimization because each deciding arc within the problem acts as a component of the network, wherein the arc is whether you should buy the tractor at this price and at this time or not. So network optimization gives us a visual and conceptual aid of the decision-making process of management. More of this will be discussed later in this presentation. And in general, these networks provide a flow of some type, which comes from an origin. And in our case, the flow presented will be the amount of money spent for purchases. It is through this model that we will be able to minimize the total cost of purchases.
Moving forward, we will now visualize the problem by creating a network model. As mentioned, a tractor the company will buy will be utilized for 3 years since a mechanized luggage system will be integrated into the operations by then. As shown in the model, the circles represent the year at which the tractor would have been utilized. Starting off at the first circle, if the company were to sell it at the first year, this would cost $8,000, whereas if it will be sold at the coming year, it will cost $18,000, while if it will be sold at the third year, the cost will be $31,000. However, if the company would buy the tractor a year from now and sell it at the second year, it will cost $10,000 and $21,000 should they sell it at the third year instead. Finally, if the company will buy it at the second year and decide to sell it at the third year, it will cost $12,000.
Okay, so to explain our model, I would first explain the data. So everything you see in blue is already given in the problem. The cells highlighted in yellow are our changing variables to know our optimal solution. The one in orange is our objective, wherein our goal is to minimize the cost. So moving forward, as mentioned in the problem, the company would need to buy and use a tractor in a span of 3 years only, since they would no longer use it in the following years due to the mechanized luggage system. So to explain the created spreadsheet model, we inputted in the years first of when the company may buy and sell the tractors, followed by its corresponding costs. So when the company buys a tractor now and sells it on the first year, that would cost 8,000, and if they sell it on the second year, that would cost 18,000. And if they sell it on the third year, then it would cost 31,000. On the other hand, if the company buys a tractor after a year and sells it on the second year, that would cost 10,000 and 21,000 if they sell this tractor in the third year. Lastly, if the company buys on the second year and sells it on the third year, that would cost 12,000. So moving forward with the column under action. So we name this action since the data here would tell us what years it is best for the company to buy and sell the tractors within the 3-year span. So later on, when we solve, we will see the numbers 1 and 0, wherein 1 is where the action should be done. So going to our nodes and constraints, the nodes corresponds to the years. And since we need to have a tractor now and dispose of it after the third year, we have this following constraints. So 1, 0, 0, and -1. With that said, we need to have the flow of buying and selling tractors equal to the constraint. And to get the flow, we just need to get the sum of the tractor bought for the year and subtract it with the tractors sold for the year. So to get this in Excel, we need to use the sum if function. So when we select the sum if function, we will find the range, the criteria, and the sum range. So our criteria is the node. The range is where we can find the node, and the sum range would be the action wherein the data here would be added if our criteria or node is seen in our range. So to continue with our equation, since we named our cells, this would be somehow easier for us to reference already. So our range for the first sum, for the first sum if function is the buy. Our criteria is the current year, and then our sum range is the action. Since our cells are named already, we can just drag it like so, wherein our criteria would be the only one to change. So the nodes. So if your cell are not named to utilize the dollar sign. So for our total cost, this would just be the sum product of our actions and the cost. That is it for the data found in our spreadsheet model. Going to our solver. So our set objective is to minimize the total cost. Our changing variable cells are the ones highlighted in yellow are our action. Then we only have one constraint, and that is to have the flow equal to the constraint. We make sure that this is in simplex LP and check this one on negative, and then click on solve. Then click OK. Then we get our optimal solution of buying in the current year and selling it after a year, and then buying the tractor again in the first year and selling it on the third year. So this would minimize our cost to 29,000. Thank you.
So now for the equation, let x1 equal the action for buying in a year 0 and selling in year 1. x2 equals the action for buying in year 0 and selling in year 2. x3 is equal to the action for buying in year 0 and selling in year 3. x4 equal the action for buying in year 1 and selling in year 2. x5 equal to the action for buying in year 1 and selling in year 3. x6 is equal to the action for buying in year 2 and selling in year 3. y1 equals representation for year 0. y2 equals representation for year 1. And y3 equal representation for year 2. y4 equals representation for year 3. Now, for where action equals x1 plus x2 plus x3 plus x4 plus x5 plus x6. Then buy equals the range of the years for buying. Then sell equals the range of the years for selling per. Then, for objective, minimize equals sum product, parenthesis, action, comma, cost, parenthesis. Then, subject to sum if, parenthesis, buy, comma, y1, comma, action, parenthesis, sum if, parenthesis, sell, comma, y1, comma, action, parenthesis, equals 1. Sum if, parenthesis, buy, comma, y2, comma, action, parenthesis, sum if, parenthesis, sell, comma, y2, comma, action, parenthesis, equals 0. Then sum if, parenthesis, buy, comma, y3, comma, action, parenthesis, sum if, parenthesis, sell, comma, y3, comma, action, equals 0. Then last, sum if, parenthesis, buy, comma, y4, comma, action, parenthesis, sum if, parenthesis, sell, comma, y4, comma, action, equals -1.